Okay, what I would like to discuss today is logarithms. Now, because of the lighting conditions in this room, it's possible that the camera will fade in and out of focus from time to time. I'm watching my computer screen, and if it goes completely out of focus, I will pause until it gets itself back into focus. So, logarithm, essential definition is the exponent which would make it happen. All right, so we'll start with a few illustrations to talk about what they are. Later, we'll get to calculating them, but for now, I just want to show you what they are, what it means. Okay, so illustration number 1, 2 cubed is 8. Okay, I think that's pretty simple. Now, so logarithm base 2 of 8 is 3. Okay, what I am saying, log base 2 of 8 means if 2 is the base, I would need exponent 3 to get to 8. All right, so illustration number 2, logarithm base 3 of 9 means 3 to what unknown power, that's a question mark, equals 9. 3 to what unknown power would give me 9? The answer, 2. So log base 3 of 9 is 2. Okay? For my third illustration, illustration number 3, 12 to the negative first is 1/12. So, log base 12 of 1/12 is negative 1. All right? Number 4, 1, or let me put it a different way. 625 to the negative second is 125 to the negative second is 1 over 25 squared, which is 1/625, which is 0.0016. All right? So, log base 25 of 0.0016 is negative 2. All right? It's the exponent that would make it happen. All right. Number 5. Six to the 0th is 1. So log base 6 of 1 is 0. Okay, it is the exponent which would make it happen. All right, I'll try to write that more clearly. Number 5, log 6 to the 0th is 1. So log base 6 of 1 is 0. Number 6, 40, the square root of 49 is 49 to the 1/2 power. Which is 49 to the 0.5 power, which is, the square root of 49 is 7. Okay? So, log base 49 of 7 is 0.5. Okay, it is the exponent that would make it happen. Okay, special logarithms. Okay, you guys might have noticed that on a scientific calculator, you'll see buttons for LOG. in that case, it's assuming base 10. Okay, so this is called a common logarithm. Common logarithm. Base 10. So log of k, unless given reason to do otherwise, log of k means log base 10 of k. Okay? I.e., log of 1,000 is equivalent to log base 10 of 1,000. All right. Now, if you hit the log, and on most calculators, if you type in log and 1,000 and enter or equals, you will get 3. Note, 10 cubed is 1,000. All right? Natural logarithm. Base E, where E is approximately 2.71828182845.9. Okay? Actually, like pi, it never ends. Okay? It's also non-repeating. All right, and what this means is the natural log of some number k equals log base E of k. All right, so if you type, i.e., ln of 31 equals log base E of 31. All right, so, and that's approximately equal to, if I round it to 3 decimal places, that's, hold on, I'm going to pause it. I'm actually going to get a calculator. All right, so here we go again. I.e., the natural log of 31 equals log base E of 31, which is approximately. So I'll type in the ln, on this calculator, it's ln 31. Most calculators, you hit the ln key, 31, enter or equal. Okay, I got approximately 3.434. Okay? Now, note, 2.71828182845.9 to 3.434 power. Okay, I'm actually going to enter that into my calculator. 2.71828182845.9, generic exponent button, 3.434 is approximately 31. So E to the 3.434 is also approximately 31. You can, to raise E to a power, hit shift or second ln, and then 3.434. All right. Other logarithms. Other logarithms. This is an important pair of formulas. Other logarithms. Okay, I have decided to redo the second part of the video focusing on other logarithms. Okay? So I had erased the board, and as a result, and I had to rewrite all that, and so it may not look the same as it was originally. All right, so other logarithms. Log base B of k the most common change of base formulas, because these are called change of base formulas, log base b, whatever the base is of whatever number, is natural log of the number over the natural log of the base you want to use. Other textbooks still use the old common log over common log. Now, it could be any base. You could do log 2 of a number over log 2 of a base, or log 3 of a number over log 3 of a base. But most calculators only have ln keys and log keys. Now, this is used in most textbooks, and this is more useful. This formula is used in most textbooks and is more useful. This was the common formula used in the 1980s and the 1990s. The 21st century is increasingly uses this one. I'll be doing problems with both formulas. Okay. So example 1. I'll start with one that is fairly familiar to everybody. Example 1. Log base 5 of 25. Okay. Now probably everybody reading this is thinking it's got to be 2, because it means 5 to what power would give me 25, and that would be 5 squared. Okay. But we're going to do it using both options. Option A and option B. All right, so option A would be log base 5 of 25 is, I'll use this formula, natural log over natural log. I want the log of 25. I want the natural over the base 5. Okay, so ln over ln. Ln of 25 over ln of 5. Now most calculators, you'll just type in the ln, hit your ln key on your calculator. 25, I got 3.2188758, blah, blah, blah. Then I will hit the division key, ln 5. I got 2 right on the nose. Okay? Similarly, I could do it using the common log formula. Log base 5 of 25 is log of 25 over log of 5. All right, so I hit the LOG key on my calculator, 25. I got 1.39794, blah, blah, blah. Divide by log of 5. I got 2 right on the dot. Okay? Note, 5 squared is 25. Okay? You don't need to do this step. If it just asks for the log, you just need to stop at 2. Okay? But I'm trying to make the connection between logarithms and bases. Logarithms and bases and exponents. All right. Example 2. I want log base 4 of 128. Option A. And option B. All right, option A, I want log base 4 of 128 is, this time I'll start with a common log formula. Log of 128 over log of 4. And I'll type in LOG, 128, I get 2.1072, blah, 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 blah. I'm going to hit the division key, log 4. I get 3.5. All right? The other option is to use this formula. So that'd be the natural log over the natural log. I'm taking the log of 128. The base I want to use is 4. So I'll type in ln 128. I get 4.852 something. All right, so 4.852 something divided by ln of 4. I get 3.5 again. All right. All right, example 3 is going to be 6 to what unknown power? I'm going to write it bigger. 6 to what unknown power equals 1296? Well, what we would do is log base 6 of 1,296 would be, I could use either one. It doesn't matter. Doesn't matter. Either one is fine. I'll use this one. So that's going to be the natural log of 1,296 over the natural log of 6. All right, so I'll type in natural log of 1,296. I'll get 7.167. I will hit the division key, natural log of 6. I got 4. All right? Example 4. 32 to what unknown power gives me 512? Well, log base 32, because that's what the question asks. I'm going to need the logarithm of this base to find out that unknown power. Well, this time, again, you could use either one of them, but I choose this one. Log 512 over log 32. All right, so I'll type in log of 512, hit enter or equal, then I will divide by the log of 32. So when I type in log of 512, I got 2.709, blah, 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 blah. Divide by the log of 32. I got exactly 1.8. Okay, note, 32 to the 1.8th power is equivalent to 32 to 9/5, which is equivalent to the 5th root of 32 all to the 9th power. And the 5th root of 32, folks, is 2. So 2 to the 9th is 512. Your calculators could confirm it. Okay? So 32 to the 1.8th power is 512. Okay? Again, I'll remind you, these exponents, these logarithms, represent the exponents that would make it happen. And as you can see, 32 to the 1.8th power would be 512. You can see the details there. All right, I'm going to erase the board and put some new examples on the board. So, example 5. Approximate log base 36 of 11 to 3 decimal places. All right. Again, it doesn't matter which one you use. Okay? Do. I choose log over log. So, log base 36 of 11 is log of 11 divided by log of the 36. All right, so I type in log of 11. I get 1.04 blah, 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 divided by a log of 36. I get approximately 0.669, rounded to 3 decimal places. All right? Example 6. Approximate log base 60 of 33 to 3 decimal places. All right, so do I choose ln over ln? And you don't need to write that out. I'm just illustrating what I'm going to be doing. So, log base 60 of 33 is the natural log over the natural log. I want the natural log, I'm wanting the log of 33. The base I want to use is 60. All right? So, ln of 33, enter or equal, I get 3.4965, blah, 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 divided by a natural log of 60. That gives me approximately 0.854. All right? Note, let me put a note up here. Note, do not change this to log base 60 of 33 equals the ln of 33 60th into, or sorry, do not reduce your fractions. No, don't do that. Okay? Do not treat this as fraction reduction. Use exactly the numbers. Okay? So let me remind you, let me be very clear about that. Use the actual numbers. Do not reduce. Okay? Do not treat this as fraction reduction. Use the exact numbers. All right, let me get these off the board. Example 7. Okay, example 7. Approximate log base 45 of 797 to 3 decimal places. All right, so do log base 45 of 797 is, I'll use this one. Actually, I think I'll use this one. Natural log of over natural log of, the logarithm I'm looking for is of 797. The base I want to use is 45. All right, so I'll type in natural log 797. I get 6.68 blah, 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 divided by a natural log of 45. That comes out as 1.755. Okay? Example 8. approximate log base 24 of 175 to 3 decimal places. All right, so do log base 24 of 175 is, this time I think I'll use this one, log of 175 over log of the base I want to use, 24. All right, so log of 175, I get 2.243 blah, 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 divided by the log of 24. I get approximately 1.625. Okay? Note, 24 to the 1.625 power equals 24 to 13/8, which is equivalent to the 8th root of 24 all raised to the 13th power. So that will be 24 to the 1/8 power to the 13th power. All right, so I will take 24 to the 1/8 power, and then I'm going to take that value and raise it. I got 1.4, so for this, the 8th root of 24, I got 1.4877378, blah, blah, blah. Okay, and now I'm going to raise that. Actually, what I'll do is I'll go ahead and write something out. 1.4877378 to the 13th power. So 1.4877378 to the 13th power gives me 174.92, which is really close to 175. Okay? Almost 175. Okay? So all these notes are to illustrate that these exponents, these logarithms, have relationships to exponents. Again, the logarithm is the exponent that would make it happen. So since 2 cubed is 8, log base 2 of 8 is 3. It's the exponent that would make it happen. Okay? And I am done.